All right. When you are manipulating expressions around, um, like sometimes things just don't work out really the way that you want. You wish you could be slightly different just to make things convenient. Like for me, on that last example, which we did, if I had had parentheses around -1 +1, I definitely would have combined those together to 0, right? So the question is, how can we make these things more convenient for what we want to actually do? Um, those are equivalent expressions right there, but it was I kind of missed out on a step that they kind of wanted me to do because it wasn't written the way that order of operations really wanted to have it. Oh, sorry, you can't really see it because my video there. Let me move that out of the way. So that's how I'd kind of change that one. So we're looking for properties that allow us to do these different kinds of things, and uh, we have some commutative property. Let me erase those things that I just had there. I don't really need those for a minute. The commutative property is a property that just says the order in which you add things or the order in which you multiply things does not matter. 3 plus 5 is 8, which is the same as 5 plus 3. Both of those things are equal to 8. It doesn't matter whether you do 3 plus 5 or 5 plus 3. Same thing with multiplication. 3 times 4 is 12. Well, guess what? 4 times 3 is also 12. Those are equivalent expressions. So the commutative property allows you to switch the order in which you do them. Uh, think of it like commute, like a car. You're changing locations. You're commuting from Santa Rosa to Ukiah. You're just switching back and forth. But when you're all done at the end of the day, you still end up at home, right? Back in Ukiah, or back in Santa Rosa, wherever you started from. So that's the commutative property. The associative property, and this is the one that I wish I had had for that last example, says if you have numbers, say like 2 plus 3 plus 4, you can choose which of the three numbers to add together first. I can add 2 plus 3. You get 5, plus 4 is 9. That's totally fine. But I could have also said, you know what, with 2 plus 3 plus 4, I want to add the 3 and the 4 together and get 7. And then add the 2, which guess what? Is still 9. So the associative property lets you just say, if you have multiple of addition in a row, or multiple of multiplication, you can decide which one you get to do first, which is nice because sometimes it's convenient to multiply some numbers instead of others. For example, let's do 3 times 4 times 5. Now, when I'm looking at this problem, I'd like to multiply 4 times 5 together because it's 20, and 20 is an easy number to multiply by anything else again, right? It's just one of those ones I just have memorized super quick. So I'm going to choose to do 4 times 5 first. And now I have 3 times 20. Well, I like multiplying by 20 because I can ignore that 0. 3 times 2 is 6. Stick that 0 back on there, and I've got 60. So that's what the associative property is all about. All right. Now, I'm going to go on to the next example here, and we're going to do some party planning, actually. And I'm going to have to move my video out of the way here, just to give myself, make it so that you can see the table. All right. So, example 2, applying properties of numbers. Eric makes a list of items that he needs to buy for a party and their cost. Find the total cost of those items. So you can see this table here on the side. It's telling us we got a cost for balloons. He's spending $6.75 on balloons. He's spending $14 on decorations. $23.25. Oops. And 25 cents on food, and $20.50 on beverages. Now, we're going to try to think about which one of those properties might be able to help us out. Now, I was a cashier for years when I was in high school. Well, I was a courtesy clerk, and then I was a cashier for a while after that. So I got really used to adding change together. And I don't know about you, but whenever I see 675, I know that's 3 quarters, right? Like 3 physical actual quarters in money. And if I have a fourth quarter, I make a full dollar. So when I see that 75 and the 25, I wish they were right next to each other so that I could add those two together, because it's going to give me a nice round number. So that's what I'm going to do. I'm going to rearrange those so that 675 and 2325 are next to each other. Now, to do that, all I'd really have to do is change the location of the $14 on decorations and the $23 on food, and I'd have what I want. The property that allows you to switch the order, that's the commutative property. So, I'm going to do 675. Oh, wait, you know what? The 675 isn't changing. It's still in the same spot. So 675. But the $23.25 and the $14 even changed locations. 2050. All right. So now I'm going to add these things together here. 75 cents plus 25 cents is a full dollar. So this really becomes $7, and this becomes $23. Well, 7 plus 23, that's $30 even. Plus, well, I could add the $14 and the 2050 together. 14 plus 20 is 34. And because the $14 didn't have any change into it at all, it's just 50 cents. The 0.5 is just hanging off there. Now I got another number with no change on it, so I know my answer is just going to be 0.5, or sorry, 0.50, because we're talking about dollars. 30 plus 34, that is $64.50. So the commutative property made that problem easier to do in my head, right? Because I could have done 25 plus 2050, had another 75 cents, and I'd have to know that 75 cents plus 75 cents is $1.50 later on. But it just made it more convenient for me. So that's what the commutative and associative property are all about, making the problem more convenient for you. So this was another kind of long video, but I got one or two more for you.